Hello guys, this is Strauss Robinson II. This is my second video, and in this video I will be doing exercise 4.2, which is a number theory question. I found this problem to be very interesting. So for exercise 4.2, it says suppose that a comma b comma c are positive integers for which a square root of 3 plus b over b square root of 3 plus c is an integer. It says prove that a plus b plus c divides a squared plus b squared plus c squared. Now, looking at this problem, I found it to be very confusing, but when I look at the notes, I found some definitions and theorems that I think that's going to be useful. So I feel like for this problem, definition 4.1 and theorem 4.1 is going to come in handy, the properties of divisibility, because it's asking me to prove that a plus b plus c divides a squared plus b squared plus c squared. So I thought the first step was like getting this definition. And if I scroll down, we can look at definition 4.4. And this kind of talks about let m and n be integers, not both of them 0. It says let an integer d is called the greatest common divisor of m and n. Okay, it explains this. And then it starts talking about how we say that m and n are relatively prime when the greatest common divisor between m comma n is equal to 1. And it says we define the greatest common divisor 0 comma 0 equals 0. And since this problem is like a Pythagorean problem, I thought it made sense to kind of like copy and paste the definition for this as well. It says a triple of positive integers a comma b comma c is called a Pythagorean triple whenever a squared plus b squared equals c squared. This Pythagorean triple is called primitive whenever the greatest common divisor of a comma b comma c is equal to 1. And then it starts to give some remarks that I felt like was pretty useful. It just shows that any Pythagorean triple can be kind of generalized like with a formula. And it also shows that that a Pythagorean triple is primitive if and only if a comma b comma c are pairwise relatively prime. So when I saw that, that's what triggered me to copy and paste definition 4.4. So I thought definition 4.4 and the remarks for the Pythagorean triples were connected. So for this problem, I see basically 3 integers. I see a is an integer, b is an integer, c is an integer, and then you have this rational expression, but it's actually an integer. So I'm gonna try my best to prove that a plus b plus c divides into a squared plus b squared equals c squared. So right now I'm gonna go ahead and solve the problem the best that I can. So if I go down here, I'm gonna rewrite the integers. So yeah, we have the following integers. So the total integers, I think I said before, we have 4 integers. So we know a is going to be an integer, b is an integer, c is an integer, And then we have a square root 3 plus b. And then we also have b square root 3 plus c. So those are our four integers. And then what's next is, so what it's asking is it wants me to prove that basically it wants me to prove, yeah, okay, I got it. It wants me to prove the following: a squared plus b squared plus c squared. Can this be divided by a plus b plus c? And this is very interesting. So like, just looking at this problem, the way like I'm looking at the problem is kind of you could do something like this. You have a times a, then you have plus b times b plus c times c over a plus b plus c. And then I think what you could do is you can kind of simplify this more. This could look like a times a over a plus b plus c plus b times b over a plus b plus c plus c times c a plus b times c. And what you could do now for this problem is that you see a times a over a plus b plus c. So since you see this, one of the a's can potentially cancel. And then likewise for this rational expression, one of the b's would cancel. And then for this fraction right here, c can cancel. So you could have a over b plus c plus b equals a c plus c over a plus b.